This is Chapter 12, where we will be discussing food and the impact that microbes have had in food production. Microbes are involved in the formation of a lot of different things that we enjoy to eat, and a few things that you might not even expect. Looking ahead in this chapter, you should be able to name many of the variety of foods that owe their existence to microbes and understand that the fermentation process and how it is used in the production of numerous foods. List some of the microbes whose beneficial effects are employed in the food industry, and summarize the industrial and microbial processes used to produce many foods we enjoy. You should also be able to describe how spoiled food can be advantageous to our health and act as a safeguard against microbial contamination. Recognize that microbes contribute substantially to our way of life and appreciate the many contributions. And increase your vocabulary related to microbes and to foods. Now, we're going to take the approach of a meal in this discussion. We're going to start with appetizer and work our way right through to dessert, and we will talk about different things that we can have in these meals. So, at the beginning of our meal, perhaps we would have a glass of wine. Now, wine is grape juice that is fermented by yeast. And there are a couple of different wines. There are red wines, which come from black grapes. They are processed using the skins and the stems. And then there's white wines, which can be black or green grapes. And what happens there is that the skins and stems are removed. Now, once you've squeezed the juice out of these grapes, then you get a fermentation process. There are yeasts that actually grow naturally on the surface of grapes, and these can be mixed in. In older wines, this was where the yeast came from. However, now we tend to want to use a very specific type of yeast in the production. Now, yeast is plentiful in vineyards and orchards and all sorts of fruit-bearing things because they utilize the sugars from the fruit for energy. And you can have Applejack, which is an alcoholic apple juice. You can have peaches, which will make kind of a peach-flavored ethanol, barley-flavored ethanol, which is in the end beer. So different microorganism, or same microorganism, different substances that this organism works on. And what we can see here actually is an image of one of the yeasts and the end product, a bottle of wine. Now, the microorganism involved here is Saccharomyces ellipsioides, and it is crushed naturally with grapes for fermentation. This is the one that grows on the surface of the grape. It can also be added to grape juice in controlled fermentation. That's when we have basically pasteurized the grape juice so that we can now put the specific kind of yeast that we want to and avoid some contaminations. What it does is it does an aerobic breakdown of glucose first, so that's in the presence of oxygen. And there is carbon dioxide that is produced. Now, eventually in this process, the yeast settles to the bottom and it starts an anaerobic breakdown of the remaining glucose. So in that situation, in the absence of oxygen, it has to switch to a fermentation type process, and the byproduct is ethanol. Instead of carbon dioxide. Now, the downside to that for the yeast is that it's polluting its environment. And so once it reaches about a 13% alcohol content, the environment is no longer suitable for the yeast to survive, and they die off. Now, of course, we could make a wine in a matter of just a few days. You can take a mixture of fruit juices, you can put in the yeast, and you're going to have alcohol within a short period of time. But you're not going to have the unique flavors that different wines have, and that comes from aging, which can take weeks to months. Aging can be done in casks, oak casks. It can be done in the bottle, but all of these processes develop a flavor, an aroma, what they would call a bouquet. There are variations on fermentation that come in play as well, depending on how much sugar gets broken down. So what we call a dry wine has had all of the sugar broken down. A sweet wine has some sugar left. Champagne, actually, there is a second fermentation inside the bottle. After the first fermentation, sugar is added and then it is bottled. It is this fermentation that gives it the bubbly. And there are dessert wines which really kind of fortified. They have extra sugar in them. We will talk a little bit more about those in just a second. Actually, we will address the dessert wines at the end when we get to the dessert, but for now, understand that dessert wines are a fortified wine. They have had flavors, sugars, additional alcohols added to them, so they are not quite the same product that we start out with. Now, as an appetizer, olives, very popular, olives, cheese, crackers, all of that. But truthfully, olives just picked right off of the tree are just nasty bitter. And there is a whole process that involves microorganisms that allow these olives to get to the state that we think of. So we have fermented olives. And if we're talking about green olives, what we're taking is unripened olives, and they get soaked in sodium hydroxides, which help neutralize the bitterness. They are washed and covered in brine, salt water. There are microorganisms that function very well in the salt water, which will basically pickle these things. So we seal the olives in casks with this salt water, and then bacteria on the skins ferment and enhance the flavor. And if treated above, what we get is a fermented Italian olive. Now in Greece, we get black olives, and the olives are allowed to ripen on trees. They are picked, and again, they taste awful at that point. But they are exposed to air for several weeks, which allows microorganisms to work on them, and ultimately you get black olives. Now, these are not like the black olives that we get in the cans at the store. These are much more flavorful than those types of olives. Now, I don't know too many people who don't like some form of cheese. And the process that we start with is pretty much the same. We've got a microbial conversion of casein, which is a milk protein. Now, all this starts by curdling, and there is an enzyme called rennet, which is derived from the stomachs of cattle, that is mixed in there that causes this to form curds. Curds are unripened cottage cheese. Now, once we have taken those curds, we can ripen it. The curds are washed, we add salt, cultures of microbes are added, and it is aged. And salt content, the type of microorganism that is used, etc., and the time that it's allowed to age give us the different types of cheeses that we are familiar with. For example, we have Swiss cheese, and the microorganism there is Lactobacillus. It produces acids that lead to a sourness. And then there is a Propionibacterium, which produces some organic chemicals and carbon dioxide. And it is that carbon dioxide that sort of makes bubbles and creates these holes. And it's a combination of these two microorganisms working together that give the cheese its flavor. Now, aside from bacilli, cheeses can be ripened with fungi as well. Cultures of microbes that are added, consider Penicillium camemberti, which is used to make camembert. Protein, it digests the proteins and softens the cheese. Roquefort, there is Penicillium roqueforti, which penetrates cracks into the curds, and it produces actually those blue-green veins that we think of as a component of blue cheeses. Now, at one time, the process for getting these molds to start forming on these microorganisms involved, or on these cheeses, would involve the process of getting some dung, cow dung, and rolling the cheese in that. That's no longer the process. Now we can get spores and put the cheese, roll the cheese in that, and ultimately we'll get the product that we are interested in. Vinegars are also a really important food stuff, or food material. We put vinegars on salads, on fish, on a variety of things. And vinegar consists of acetic acid, which is produced by souring of wine. Apple cider vinegar is just apple cider wine. It's still a fruit product with continued fermentation. Clear white vinegar, instead of using a fruit, we have potato starch. So we get this fermented into a potato wine, which is sort of the origins of vodka as well. Again, continuing the fermentation to vinegar. It was said, wines left too long turn to vinegar, and it's true. The fermentation process just continues and changes a little bit, ultimately giving you this soured product. Now, balsamic vinegar, same kind of thing. You've got this vinegar, only in this case it is stored in fir barrels for a period of time and absorbs the flavors that come from the wood. Wine vinegar, that flavor is really determined by the compounds that were in the original wine. Now, there can be rice wine vinegars. There can be a variety of different vinegars. Red wine vinegar, also very popular. Now, while it's not mentioned here, the bacterium involved is Acetobacter aceti, which makes that acetic acid. It grows on wood shavings, and actually in Germany they were producing vinegar as opposed to just letting the wine go bad. They were intentionally producing the vinegar. There was a object called a vinegar generator filled with wood shavings, gravel, and it had those naturally occurring cultures of that particular bacteria. As the alcohol would percolate through, the bacterial enzymes would convert that into acetic acid. Ultimately, what you're going to do is you're going to get an acetic acid content of about 3 to 5%. We're going to stop at this point and pick up our discussion of food with breads in a subsequent presentation. So, hopefully this has been helpful to you. Thank you.